We'll have a look at Simpson's rules now. Just before we do, I'll just have show you a quick sketch here. If we want to know the area of a rectangle, it's very straightforward. Length times breadth. Whatever that is, length, whatever the breadth, multiply one by the other, that's our area. However, if we've got to find the area under a curve, it's a little more difficult because all this area here of the rectangle isn't part of the curve. So we have to work out how we can get this area under the curve, and we use what are called Simpson's rules. It was Newton that designed them, but for some reason they're called Simpson's rules. So let's have a look at the rules. There's two rules, Simpson's first and Simpson's second rule. We'll look at the first rule first. When we look at the curve here, with two values that we need to know to use Simpson's rules. We need to know that the distance between each of what are we called ordinates, so all these straight lines are ordinates, this distance between them must be constant. It must be the same between every ordinate. And on this curve here we can see it's 10 degrees. 0, 10, 20, 30, 40, 50, 60. So if we wanted to work out the area under the curve to 60 degrees, all these ordinates have to be the same. 1, 2, 3, 4, 5, 6 ordinates. They have to be the same. These common intervals, 1, 2, 3, 4, 5, 6 common intervals have to be the same. Okay? The ordinate is measured from the baseline to where it touches where the ordinate touches the curve. So at 20 degrees it would be measured from 0 to this point here. On the curve, on the left hand side, these are the values of GZ. So this is the GZ curve that we're going to find the area under the curve. So there are all the values of the ordinates, and then we have the common interval. So it says here that an ordinate is a distance from a fixed reference line. Well, our fixed reference line, of course, is the line here. So one problem that we have, up at the side here we've got metres, so the measurement of the ordinate would be metres, but along the baseline here we've got degrees. How we get round this is converting our degrees to what we call radians. And a radian, 10 degrees, or 1 radian, we have to divide by 57.3 degrees. The 57.3 degrees comes in by the circumference of the circle, which is 2 pi. So if you divide 360 degrees by 2 pi, you'll get 57.3 degrees. So let's have a look at the discussion regarding Simpson's first rule, and then we'll have a quick look at the example. We always use this first rule when the ordinates are odd numbers, i.e. 3, 5, 7, 9. So the rule says that it's, how we work out the area, it's 1/3 times h. H is the common interval, so in this example it would be 10 divided by 57.3, which is the radian, and then we've got here 1, 4, 1. So 3 ordinates, 1, 4, 1. 5 ordinates, it would be multiply 1, 4, 2, 4, 1. 7 ordinates, 1, 4, 2, 4, 2, 4, 1. And we can see how they're set out here. So 3 ordinates, 1, 4, 1, 1, 4, 1, becomes 1, 4, 2, 4, 1, becomes 1, 4, 2, 4, 2, 4, 1. So let's see how that relates to the curve. On the curve here, at 10 degrees, our ordinate is 0.2. At 20 degrees, it's 0.52, and so on and so forth. So we've got from 0 to 60 degrees, we've picked off all the values of GZ. And we need to determine the area up to the 60 degrees. The common interval is 10 degrees. So all these intervals have got to be exactly the same. So on the left hand side here we write the angles, 0 to 60. The ordinates that we've measured, 0, 0.2, 0.5, 0.95, 1.22, etc., etc. Then we apply our multiplier. This is where the 1, 4, 2, 4, 2, 4, 1 comes in. Had we just had 3 ordinates, it would be 1, 4, 1. Had we had 5 ordinates, it would be 1, 4, 2, 4, 1. Because we've got the 7, it's 1, 4, 2, 4, 2, 4, 1. We multiply 1 by 0, 4 by 0.2, etc., etc., until we get our total sum of products for the area of 13.48. Once we've got that, we can work out the area under the curve to 60 degrees. So it's 1/3, always, this value is always 1/3 for the first rule, 1/3 times h, which is the common interval, which is 10 over 57.3, multiplied by the sum of the products for the area, and it gives us 0.784 metre radians. So that's the area under the curve when we use Simpson's first rule, and that's when the number of ordinates are odd.